No, this is not difficult because you've seen this before.
Yes.
It's a right triangle. We'll call this leg A, we'll call this leg B, and what do we call this side that's opposite the right angle? The hypotenuse. So we'll call this, oops, that's an ugly L. We'll call this one of the legs, we'll call this a leg, and we'll call this the hypotenuse.
Aren't we learning theorems today?
We're going to learn a couple theorems. But this is a theorem. This is a very famous theorem, and you already know it.
What is it called?
Hey, Mr. Hammer.
That's correct.
How do you know which one's the legs, though?
Because they're the ones that are not opposite the right angle. See? Okay. But we're going to do a little bit more with this today, okay? So let's pay attention. All right, there's a lot. You guys are all hyped up on something. I don't know what's going on. But you guys got to settle down.
On that,
All right?
not whatever.
Kaylin, you're part of the... Scrap, please, okay? I'm being very polite. Did the sixth period class tell you the other day that I yelled and screamed at him?
No.
I didn't record it. I paused it before I did. Okay.
Why?
Because I didn't want the world to hear me yelling.
Why were you
All right, just because I did. Just because they needed it. They needed it. All right. Stop rushing here. Okay, here we go. Here's a right triangle. Now you know what we're going to do. You guys have already said it. A couple of you already said it. But we're going to do a little bit more with that. But let's just start from the beginning. We are going to learn a thing called the Pythagorean Theorem, which, again, we've already talked about earlier this year, didn't we? Pythagorean. Where'd they get that crazy name from?
Korea.
From Korea? Pythagoras. Very good.
That video we watched.
Okay. What video did I show? Oh, that's right. Yeah, that YouTube video. Oh, I can't spell. Pythagoras. Okay, there we go. Right, it's named after some old Greek guy. Well, he's a dead Greek guy now. But Pythagoras, way back, I've looked him up and I used to remember the dates, but my memory is horrible and I can't remember the dates. I think it was BC. I'm not really sure, but it's around there. I just picture him as one of these guys in a robe walking around the desert and people following him and giving philosophy of life and all that kind of stuff. And that's what he was. You know how Jesus had disciples? Listen, please. You know how Jesus had disciples? It was not in that day. It actually was not unusual for a guy to be walking around and people following that person. That's how they taught. They didn't really have schools like, okay, we're going into ninth grade and all that kind of stuff. They didn't really have that. They would just learn. It's kind of like a mentorship thing, right? And that's how they learned back then. And so there was a lot of these guys. You've heard of like Aristotle and Plato and guys like that. Okay, these guys. These guys were teachers, and people would follow him around. And Jesus wasn't the only one that had people that would follow him around. Now, of course, he set himself apart from these teachers because he was the Son of God, and he wasn't just a teacher. I mean, he actually was God, and these guys following around gave everything up to follow him and just transform their lives. But these guys walked around. But this guy, he was kind of like a philosopher of life. He taught a lot of things. He taught science and math, just life things, but one of the things that he's most famous for is this theorem. So he probably came up with this, right? He's probably the one that figured this out. Not really. They knew this theorem hundreds of years before Pythagoras was actually alive. What he did, and we're not going to go through it, but what he did, he gave a nice formal proof for this theorem. He wrote it down real nice and neat, submitted it, I think, and people, I think, understood why this theorem worked because of Pythagoras. He didn't really come up with it on his own, but we give him the name. We give the name of this Pythagorean theorem, named after Pythagoras. Go and Google him, and you'll find all kinds of information about him. All right, so here we go. Here, what is the theorem? The theorem is, I'm going to write it like this, but I'm going to write it a little different because we're going to do something. Right, I'm going to write the C first. Okay, so C squared equals what?
B squared plus A squared.
Yeah, I'll call it A squared plus B squared. Okay, so that's our theorem right there. Now, this is only true when you have what type of a triangle? It's a right triangle. That is very, very important. You cannot use Pythagorean theorem if you don't have a right triangle. So, Dion, what kind of triangle do we have? A right triangle. Okay, you can only use Pythagorean theorem on a right triangle. I'll just sketch it real quick. If you had like this and none of these angles were right angles, you could not use Pythagorean theorem. Okay, you follow me on that? Now, there's something else that we're going to learn this chapter. Well, not really, because that's for 90 degrees as well. But there is something we're going to use. I'll just say it's a law of sines, law of cosines. We're going to learn that later on in the chapter. Okay, and we'll be able to find missing sides or missing parts of triangles that are not right triangles. But for right now, we're only dealing with right triangles. You with me so far?
Yeah.
Okay. So, if you have a right triangle, the C represents what? The hypotenuse. The hypotenuse is the side that's what? How do you know which one's the hypotenuse? Opposite. See, I would put that arrow right there. It's opposite the right angle. The hypotenuse and the right angle are opposite each other. So the other two sides are your A and your B. Does it matter that this is A? No. I could have called this B, and then I would call this what? A. It doesn't make any difference which one's A and which one's B. The hypotenuse, though, is always the C. With me? Now tell me something else about this. The 90-degree angle is the largest angle in this whole triangle, isn't it? So tell me something about the hypotenuse. It's opposite the largest angle, so it's the longest side. Exactly right. Remember doing that a while back? Okay, so if this was the shortest side, then this would be if this was the smallest angle, then this would be the shortest side. Remember that? Okay, we talked about that a while back. But the hypotenuse is always the largest side. So C represents the largest side of the right triangle, the hypotenuse. We good? Okay, so that's about that. Let's do a quick little example. Let's do this. Yeah, we'll put some numbers in and just do a quick little example. I'll just make one up, okay? I'll make an easy one up, and then I'll make one that might not be quite as easy. Let's say this side, this is a right triangle. Let's say that's 3 and that's 4, and you want to find this side right here. We'll call it C. All right. Yeah, you should be able to look at it. I think we've even talked about this. Didn't we talk about it 3, 4, 5? Yeah.
No,
But
stop, I don't know it.
okay, but I'll show you. Watch. If one, listen. I'm showing you now. This leg right here and this leg right here. If one leg is 3 and the other leg is 4, the hypotenuse is always going to be 5. And let me show you why. It's because of Pythagorean Theorem. So C squared equals A squared plus B squared. Agreed? C is always the hypotenuse, so that's our C right here. The A and the B are the other two legs. It doesn't matter what order we put them in. So I'm just going to go what? 3 squared plus what? 4 squared. Okay? So C squared equals, 3 squared is 9, plus 4 squared is 16. So C squared equals what? 25. Now look, we did this in the last section, didn't we, with the geometric mean? If I have a C squared, how do I get rid of that squared? Square root. Take the square root of this. So now, what's the square root of 25? It's just plain old 5. So there you go. So C is equal to what? 5. So there you go. There's your 3, 4, 5 triangle. You see that a lot. Okay? What if this was 6 and this was 8? What do you think the hypotenuse is going to be without doing Pythagorean Theorem?
13.
10.
Why 10?
Because 6, 10, 8, 10.
2, 4, 6, 8.
Because you did what? You doubled it. That's right. You doubled this side to get 6. You doubled this side to get 8. So it was 3, 4, 5, right? So you doubled the 5 to get what?
10.
To get 10. Does that make sense?
Yeah.
Okay. So you'll see stuff like that. It still reduces to a 3, 4, 5 triangle, but they're different numbers, 6, 8, 10. That's very, very helpful to you. When you take the SATs, you know, to prepare for college, to get into college and stuff, I'll probably almost guarantee that they'll have at least one problem where it'll be a lot quicker just recognizing that it's 3, 4, 5 instead of going through the whole Pythagorean Theorem. Question? Yeah, there is. Okay. We're only going to talk about this one for right now. That's not us, right? What are we?
11.
11. Okay, I got 10 minutes. Well, about 8 minutes. All right, so what if we had this? We'll stick with this 3, 4, 5 for just a second. I don't want to...
Does it always, every side's always 3, 4, 5?
No.
So
Only when one side is 3, one leg is 3, and the other leg is 4, will the hypotenuse be 5.
Yeah, but like you took it and it was 6, 8, 10, like, and you just...
I'll show you an example. Watch this. What if I did this? What if I said this is 15 and this is 12, and I want you to solve for x? Why is it 9? How did you know? How did you know off the top of your head it's 9? That's right. Everything's tripled, right? Because this was 3, 4, 5, right? So if I take this, what goes into both of these? 3 does, right?
Yeah.
3 goes into this 5. 3 goes into 4. So you're looking at it and you're like, oh, wait a minute. It's a 3, 4, 5 triangle, right? But all the sides are being multiplied by 3. So if this side was 3 to begin with, what do? 3 times 3 is 9. Do you see that? That's a lot easier than doing Pythagorean Theorem, isn't it? But for the fun of it, let's say we didn't know that. Let's say we forgot all about the 3, 4, 5 triangle, but we want to do Pythagorean theorem with this. We can still do it.
But it
So
won't always be like that. Like you can't always look at it.
no,
Like,
it's
oh,
not always going to be a 3, 4, 5. No, they could be crazy numbers. They don't always come in. This is a special type of triangle, this 3, 4, 5, okay? So let's actually solve for x by Pythagorean theorem. Let's put the c first, and there's a reason for that. In just a couple minutes, I'm going to show you. So let's go 15 squared equals what? X squared plus 12 squared. So let's, might need a calculator for one of these. So let's 15 squared, if you don't know that off the top of your head, is 225. So that's 225 equals x squared plus, you know that in your head, don't you? 144. So what do? You subtract 144 from both sides, and what do you get? 225 minus 144, and that's 81. Okay, so 81 equals x squared. I didn't really need a calculator, but I just did. So now what do? Square root both sides, and x is 9, just like we said it was. Wasn't it a lot easier recognizing it was an actual 3, 4, 5 triangle and figuring it out that way? Okay, but this still worked though, didn't it? That's the key. If that 3, 4, 5 triangle makes no sense to you at all, that's okay. You can still solve for it with Pythagorean theorem. You got it? Okay. Here's the deal. What we're going to do, remember we did the if-then stuff, if P then Q, and then we switched it around to if Q then P. Remember that? So what did we call that? We had a statement, if P then Q, then we switched it around, what was it called? No, it wasn't the reciprocal. The converse, okay? It was the converse, right? So that's what we're going to do. So what we just said, we said if you have a right triangle, then, this is basically what the Pythagorean theorem says, okay? If you have a right triangle, then c squared, the longest side squared, equals a squared plus b squared. Would you agree? That's basically what the Pythagorean theorem said. We hadn't really written it like that until right now. That's what it says. If you have a right triangle, then this is true. Well, watch this. If I do the converse of it, this is what it says. If I take the longest side, C represents the longest side. So if I have a triangle, I take the longest side and I square it. And if it equals the sum of the squares of the other two sides, if I take the other two sides, square them up, and add them together, if they equal each other, then what kind of a triangle will I have?
Right.
Then you have a right triangle. Do you see that? So if I give you 5, 12, 13, okay? There you go, Kenny. 5, 12, 13. If I give you this and I say, what kind of a triangle is this? Well, we can do a test, can't we, to see if it's a right triangle. So C represents the longest side. So which one's the longest side? 13. We square it. I'm going to leave like a gap in between here. I'll put a question mark, okay? Is it equal to the square of the other two sides added up? So 5 squared plus what? 12 squared. Let's see. Well, 13 squared is 169. This is 25. That's 144. If I add those up, I get what? 169. Does 169 equal 169?
Yeah.
Of course it does. So if they equal each other right here, then what kind of a triangle is this?
Right.
That's right. That is a right triangle right there. So you can test. If I just give you 3 sides, and that's what we'll do on a quiz or a test or a homework, okay? I'm going to give you 3 lengths of a side. I'm going to say, is this a right triangle? And this is the test that you do. You don't just guess and say yes or no. All right? You actually put the numbers in and see if it works out. Does it make any sense?
Mm-hmm.
All right, let me take this a little step further. Just got a few minutes left. So this says if C is always the longest side, right? Cliff, you with me? Cliff? Hey, you there? Wake up. Head up. So if you take the longest side and square it, if it equals the sum of the squares of the other two sides, then it's a right triangle. Well, check this out. This is kind of interesting. If C squared is less than A squared plus B squared, then it's not a right triangle. It's actually an acute triangle. That's another one of our theorems, okay? It's like a converse.
Wait, don't move that.
I won't. I'll keep it right there. So if you take the longest side and square it, and it comes out to be less than the sum of the squares of the other two sides, then it's an acute triangle. What do you think? I bet you could guess the other one. If it's greater than this, then it's obtuse. Exactly right. Then It's an obtuse triangle. Does that make sense? So let's throw some numbers in and see what we get. Triple. Let me find some good numbers here. I'm trying to find an example. Oh, here we go. Just put it up there. All right, what if we have this? What if we have sides 7, 14, and 16? All right, here's the sides that they give us. And we got to decide, is this a right triangle, is it an acute triangle, or is it an obtuse triangle? So what do? Well, first of all, let's write it down. We take 16 and we square it. That's the longest side, right? And then we compare it. I'm going to put a question mark here. We compare it to 7 squared plus what? 14 squared. So let's put some numbers in. I don't know what 16 squared is off the top of my head. 16. Oh, hang on just a second. Just watch. Just finish. Stay here. Sit until this is over. So this is 256. It's an ugly 2. This is 49. And 14 squared. You should know that. It's 196. So it's 196. So what's 196 plus 49? That's 245. Now watch. Shh, guys, please watch. Okay, you're sitting here, so watch. 256 is what to 245? It's greater than. So what kind of a triangle is this? It's obtuse. Don't leave before you get a worksheet. I'm giving you a worksheet tonight.